I'm affecting Africa or other mineral rich areas to make my cell phone, you don't think about that. They don't want you to think about that. But nonetheless, the more intense your technology gets, the more land you need to get that technology. So any increases in any one of these things can influence environmental impact, and your ecological footprint is a result of the combination of these major factors. There are others, but these are sort of the main ones. Okay. You guys good with that? Sort of want to leave chapter 1 if that's okay. All right. Let's move on. All right, so for the next series of chapters, 19, 20, 21, we're going to be talking about energy. One of my goals for you in this course is to understand where your energy comes from. Okay, we take it for granted that I come in, I turn the light on, I just turned off that projector. Okay, so I've impacted a power plant somewhere. In order to get you to the point where you really, I think, have a well thought out idea about energy, I want you to get a sense of really what energy is. Because this is sort of fundamental. So the first thing I want to talk about is force. Force isn't just some general word that has to do with energy. It's specifically defined when you talk to a physicist, and force has to do with two variables: mass. Okay, so here's this cup. This has a certain mass. Now it has a little less mass. Here's this large container. So obviously this is going to have more mass than that. But you get a sense of mass. Mass is matter that takes up volume. And the other variable is acceleration. And acceleration is a change in velocity. This stuff, by the way, isn't in your book. So this is the preamble to the energy chapters. And the equation is force equals mass times acceleration. That was one of Newton's findings. And the name, the measure, the units that we put on that are called newtons. Now, I'm not going to have you doing any calculations. Okay, this isn't a physics class. But just from a general idea. So if I have this book and I drop it, okay, and it lands on the ground, it's accelerating. Okay, so it has a unit of acceleration to it, and it has a certain mass. I can weigh this book. Okay, it has a certain mass. So the amount of newtons that it exerts on the ground when it lands is a measure of that amount of force. Okay, if the book was twice the size, what would happen to the force? It would increase. If it dropped twice as far, and therefore the acceleration was faster, it would also be more force. Okay, so you have a general idea that force has to do with the size or the massiveness of something and how quickly it's accelerating. Okay? Okay, that's force. Now we have another concept called work. And with work, what you do is you start with a certain amount of newtons, or force. And you see over what distance is that force exerted. Okay, so work is force times distance. So if I push on this chair, okay, if I push on it and it doesn't move, it's not going any distance. So I'm exerting a force on it, but it's not moving, so no work is happening. But once it starts to move, I'm doing work. Okay? So all we're doing is we're taking the concept of force and we're adding a distance to it. We also have a unit that's used for measuring this, and that unit is called joules. By the same way, we could also, joules was the original unit used for it. Calories is another unit that, you can have different units for the same thing, right? So I can have distance, and I can measure the same distance either in feet or in meters, right? So in the same way, I can measure the amount of work that I'm doing either in joules or in calories. And we just talked about calories because we were talking about Big Macs, right? So I could see how many calories I'm actually spending to move this and put that in fractions of Big Macs. Probably a small fraction of a Big Mac. I don't know how far I'd have to push this chair to burn 535 calories. But we can convert that to joules pretty easily. So an energy is just a measure of work. Specifically, energy is the property of an object that allows it to produce change So energy is the property of an object that allows it to produce change in itself or the environment. So by pushing the chair, I'm changing the environment because I'm moving the chair across the floor. Okay, so I'm exerting, and energy is a measure of the amount of work that I am exerting on that. Okay, one other concept, if we take work, we said the units for work is joules. So that's like a certain amount of energy. Think of the Big Mac. A Big Mac has a certain number of joules in it. Okay, so it's a quantity of energy. But now if I take those joules and I divide by time, seconds, I get another useful quantity, which you hear about all the time. What is it, Antonio? Watts. He's got a good last name for this class. Energy. So that's watts. Okay. So a watt is a rate of energy change. Go back to our calorie example. You need 2,200 calories per day, right? I'm going to convert that. I'm going to convert calories to joules. There's 4,184 joules per calorie. So this happens to be 9204800. That's 9,204,800 joules. Okay. Anybody know how many seconds there are in a day? There are 86,400 seconds in a day. So we were saying you need 2,200 calories, or roughly 9 million joules per day to stay functioning. Okay? And a day is 86,400 seconds. If I do that and divide that, that's 106.5 watts. Well, everybody's familiar with watts, right? Because like a light bulb has a watt, like a 25-watt light bulb is using energy at a rate of joules per second. Well, guess what? You're not that much different from a light bulb. You're using energy at a certain rate too. Who saw The Matrix? First Matrix film? Remember that? Where he holds up the battery and he goes, "They've reduced you to this." And he's holding up the battery, and then basically, I mean, that was a great movie if you ever get a chance to watch it.
That's a series.
Huh?
Series.
It's a series, yeah. I don't think the other ones are. The first one's the best one. In that particular case. So those machines turned us into energy producers, turned us into batteries. So your body, you're very much like a light bulb, or probably more like a, well, that's pretty low. So you know your microwave oven, it runs at like 2,000 watts. So it's burning energy faster than you are. So that's the nice thing when we're talking about energy, because you can compare light bulbs with lawnmowers, with people, with your pet dog, and see what wattage they're operating at. All right, questions? Okay, I will see you guys on Thursday. You can go ahead and start reading chapter 19. Chapter 19. In the book.